Hello everyone, this is Ken with Power Source Electric, and I want to go over multimeters with you today. But before we do that, I want to give you a little bit of instruction on what electricity actually is. When you're checking for electricity, we want to know what we're actually checking for. It was explained to me back when I was an apprentice and how electricity works, and they used a comparison to water flowing through a water pipe. So I want to use that with you right now. If you were to take the amount of water that flows through a water pipe, that would be just like our current with electricity. So if we're measuring current, we're measuring the amount of water flowing through a water pipe. If we were measuring voltage, that would be the pressure pushing the water through the water pipe. So that's going to be our voltage, is our pressure. So 120 volts is a lesser pressure than 240 volts, but a greater pressure than 9 volts. So that's just how fast the current flows through. Current being our quantity of electricity. And the last thing is the resistance. So our current is flowing through, pushed by our voltage through a piece of copper wire, aluminum wire, but it's flowing through a wire. And the size of the wire, whether it be a number 12 versus a number 14, 12 being the larger wire, 14 being the smaller wire, would dictate how much resistance we have in our flow of electricity. So we're going to have less resistance in the size 12 wire than we would in the size 14 wire. That's why when you're looking on your breaker or looking at a circuit and you see a number 12 wire on a 20 amp circuit, and then you see a number 14 wire on a 15 amp circuit, it's because that 12 wire can handle a larger quantity of electricity going through it. So all that to lead right into our multimeter. We're going to be measuring the voltage or the pressure that's going through a piece of wire, and we're also going to measure the resistance. And basically in the resistance, I want to make sure I have a complete circuit. It's going to be continuity. Does the circuit go from A to B? So that's what we're going to take a look at. So let's take a look at our multimeter. We're taking a look at a standard multimeter. This is a Greenlee brand. I like Greenlee, I like Fluke. They both do a pretty good job. I just happen to have a Greenlee here. That's what I use. I keep in my truck. And we're just going to take a look at the different parts of it. Today we're looking at measuring the voltage and resistance. And that's pretty much basically all you need as far as measurement for the standard taking care of your house. And that's what we're all about, making sure you can take care of your house and take care of some of the basic electrical needs for your home. So looking at the multimeter, we're going to see there's two leads plugged in. There's a black lead, there's a red lead. And this is where we're going to plug in our leads to check our voltage and resistance. So let's get a little bit closer look here. You'll see the black lead is tied into the common, the red lead is tied into the plus sign, and the leads are going to be what make contact with the electricity in order to measure it. Okay, on the multimeter, I'm going to go ahead and select voltage, which is my first position, and let's take a look at the screen. So we're going to zoom in here, and in the screen we're going to notice that we're on auto, so it's going to measure whatever level of DC voltage, which is currently shown up here in the upper left hand corner. You'll see the two solid lines to the left of the 0, and that would be measuring the voltage for a DC circuit. If we wanted to change that to an AC circuit, which would be inside your home, DC would be a battery, AC would be the power coming through your plugs that power up your TV or your light fixtures. We're going to go ahead and push our selector switch, which is just below the readout. Let me see if I can get that for you here. Selector switch here. And now we're going to take a look, and you'll see a wavy line there to the left of the 0. That's telling us that we're measuring our AC voltage. Alright, so you can see that I placed the leads inside this extension cord. I'm reading 122 volts, 122.4 volts. I know that I have power, and I also know that I have a complete circuit. So this extension cord here, I know that it's going to give me the proper power to come out to my equipment if I was using a drill. If I were using whatever type of piece of equipment, I know that I have good power here at 122 volts. And I know that all of my equipment's going to work. So that's how we would check for our voltage. Now notice that I have the red lead and the black lead plugged into this extension cord. It doesn't matter which lead is on which side of the extension cord. We're dealing with alternating current, so the leads don't matter. If we were dealing with DC current or DC voltage, then we would have to make sure the polarity was right, meaning the black lead would be on the negative and the red lead would be on the positive. But here we're measuring voltage on an AC circuit, and where the leads go, where the leads touch the circuit coming in, don't have any effect on the reading. Now we were just checking an AC circuit to make sure that we had the proper voltage, and now we're going to switch over to DC. So to do that, I'm going to go ahead and push right here my select switch, and I push over, and you'll notice that in the upper left hand corner you'll see the two bars change from a wavy line to two straight lines. It says auto, so that's telling me that I can check for my DC voltage now. So let's go ahead and check that. So now we're checking DC voltage. You see the two lines that are straight. I'm on auto voltage, so it's going to tell me whatever my voltage range is. We have our two bars. We know that we're checking for DC volts. I'm going to go ahead and back off here a little bit, and you can see that I have the two leads on a standard 9-volt battery. So in this case, with this being DC, we have to make sure that our polarity is correct, meaning the black lead has to touch the negative side of the battery and the red lead has to touch the positive side of the battery. So here we go. We're going to take a look again at what our reading is on a standard 9-volt battery, and we have 9.87 volts, so we know we have a good battery there. Now if the leads were reversed, let's take a look at that in case we were to make a mistake and put the black lead on the positive and the red lead on the negative, what that's going to do. Okay, so I reversed the leads, and you'll notice we still have the 9.8786 volts being detected, but if you look in the left hand side, left of the 0, you'll see a negative sign. So we'll look right here. It's our negative sign showing that our polarity is incorrect. So we're not measuring this properly with our leads. And we'll go ahead and take a look at the leads now, and you'll see that I reversed the leads. Okay, next we're going to go ahead and switch the multimeter over to resistance, and I'm going to go ahead to the dial, move it up one. It's going to show ohms, and you're going to see OL, open line. That means that there's no resistance because there's no circuit. We take a look at the leads, they're taken apart, and there's no resistance there. So once I push the leads together, you'll see that we have a closed circuit. All of our numbers are 0, meaning the circuit is closed. I open the circuit, and we have an open circuit. So this is very handy in telling us if we have a broken wire or a broken circuit, that the circuit is not complete. Go ahead and put the leads together again, and you'll see we have a closed circuit. Alright, measuring in our resistance or our continuity, I want to show you a handy way to use your multimeter around the house. Just a standard way is checking to see if you have a light bulb that's bad. Maybe you've replaced a light bulb in a lamp and it's still not working. You don't know if you have a bad light bulb or a bad batch of light bulbs, or if your lamp is actually broken or the light fixture is broken. So we're going to take the standard light bulb, and we're going to make sure that this light bulb is working properly. So I'm going to take my leads, and I measured on resistance or continuity, making sure that I have a complete circuit. Then I'm going to take one lead and go to the base here and hold it on the base. Then I'm going to take my other lead and place it on top of the light bulb where we're making our contact. You can see that that circuit has been closed. Now there is resistance because of the filament inside the light bulb, but the circuit is closed. I know that this light bulb is good. So if I were having a problem with a light fixture using this light bulb, I know that the problem is not with the light bulb, it's with the fixture. Now in checking voltage, if we're using our multimeter and we wanted to check voltage, and we go ahead and set our meter back to voltage, and we want to check to see if our plug here, our extension cord, actually has voltage to it, we go ahead and set our voltage meter back to voltage. We select the wavy line, which is our alternating current, because this is alternating current inside our home. We can check it with our voltage detector. Go ahead and turn that on, and we bring it over to our extension cord, and we see that we have power to it. Now the difference between the voltage detector and the meter is this is only telling us if we have one side of the circuit. If we have the hot wire connected to the extension cord, if the neutral was broken or disconnected somewhere inside that circuit, then we wouldn't know it. That's where our voltage meter would come in handy. So let's go back and check and see, make sure that we have a complete circuit. We have 120 volts instead of just a hot line going to it. All right, we plugged our leads back into the extension cord. We see that we have 122 volts, meaning that we do have a complete circuit. We do have our hot and we have our neutral on this circuit. Here we have two different types of multimeters. The first one, this one that we did a demonstration on, is the one that I use. It's about a $50 to $70 multimeter. The one here on the right is a slightly less expensive $20 to $30 multimeter. They both would do the job for you in your home. You certainly don't need to spend $60 or $70 or $50 to $70 on a meter. You can do everything you need in your home with this meter here that's $20 to $30. And they're very handy to have around
Thanks
the
for
house.
taking a look at the meters with me. There's certainly a lot more you can do with a multimeter than what I've just shown you, but I didn't go in great detail. I just wanted to show you what you'd be using it for around the house. If you have any other questions about multimeters, if there's something specific you want to know how to measure with your multimeter, please hit contact us, and I'd be happy to go over that with you, give you a better explanation of it. But it's certainly a good tool to have around the house. I wouldn't spend a lot of money on them if you're not an electrician and it's just something you want to use to maintain your house. Check before you call an electrician, and that way you'll know what you're paying for as far as what the problem is. You'll be able to give the electrician a little bit of information and let him know what you've already checked. So thanks a lot for coming out and taking a look at our video on multimeters. And again, hit contact us if you have any questions. Thank you.